Hello guys. In this video I'll discuss the power rule of calculus. It's a very important rule, I would say, and very makes it more effective and simpler to solve certain derivatives. Okay, so we want to start with, well, if I wanted to find the derivatives of something, like in the previous video, the definition of the derivative would be something like this. It'd be like prime of x is equal to something f x plus h, and then minus f of x over h, right? So that's like the definition. But what if I'm too lazy to do that when I have like f of x is equal to x squared? Well, we have a thing called the power rule. This rule states that up here, because I have this 2, x squared, we bring it to the front as the leading coefficient. So that's 2x, right? But then up here what happens is the 2, the exponent is always minus by 1, subtracted by 1. So that's 2x to the first, which is the same as 2x. In other words, the derivative of x squared is simply 2x because of that. Okay, so that's more of a simple way of solving it. We also have to keep these other things in mind. That n x of m is the same as x m divided by n, right? So we have to keep that one in mind, and also we have to keep this in mind. If I have 1 over x, it's equal to x to the negative first, agreed? Because under the under the 1. So this notation, the negative 1, has nothing to do with actual negatives. It's just you flip it. So anyway, I wish to provide a few examples. Like, we will have 1 over x squared. Well, I know that it's going to be negative because it's in this form, right? It's a fraction and 1 is above it, so it has to be x to negative 2, right? But then what's the power? Well, I'll just drag this in front and it's negative 2x, but then negative 2 minus 1 is equal to negative 3, right? So negative 3. So that's the derivative of 1 over x squared. Pretty simple. We have x to the 10th. And this is a really effective method. Instead of, let me show you what I would have had to do. I would have had to do this. FOIL this out 10 times. Subtract by x to the 10 all over h. And that's the work I would have had to do. And that's insane foiling. So x to the 10, I just drag it in front. So I have 10x. And then 10 minus 1 is equal to 9. This can always be checked in your calculator. If it appears as a line tangent to whatever your original is, then it should be correct. We have, let's take x to the third as well. Bring it in front. 3x, right? But then what's 3 minus 1? That's 2, so 3x squared is the derivative of x cubed. Okay, simple enough. We also have examples like this, where uses square root. This one. Well, in the earlier rule about this, I have to convert this to an f of x format, which means it's gonna f of x is gonna equal, well, m over n, right? So x to the 2 over 3. And I do the same thing. I drag it in front, so 2/3 x, and then minus 1. That should be negative 1/3. and that is the derivative of that thing. So we also can have more complex problems, such as putting it under in a denominator, even if it's a square root. Like if I wanted to do, let's say, 1 over the one I just did, except for putting it over under 1. So, well, it's the same thing, right? I know it's going to be negative because it's under this. Therefore, when I take x of the 2 divided by 3, I know it has to be negative. So in other words, it's going to be x negative 2 over 3. Because it's under here, right? Has to be. So then you drag it in front like usual. Subtract by 1. So negative 2 divided by 3 of x. And then minus 1 is 5 over 3. That's derivative of that thing. We also have another way to apply the power rule. Because we know the property of y equals a f of x, right, is equal to y prime of a f prime x, right? So these things are equal. So this means that y equals a x to the n, right? Then y prime is equal to n a x n minus 1. So this can also work for any derivative or whatever you wish to do. Namely, if it has a coefficient, then you're bound to use it. So if it's like 4x to the 5th, like let's say f of x is equal, and I want to find prime of x, the derivative, then what I'm going to do is I'm going to plug it in like so. The n in the beginning of nax is the same n that we have as the exponent. In other words, that means I take this 5, I'm going to do 4, because 4 is the a, right? It's the coefficient. And then 5, I also have x, so I'm just going to put x in there. And then n minus 1, 5 minus 1, that's 4. In other words, when we simplify, 20x to the 4th. So that's another way to do derivatives. We also can have more complex examples, like 2, and then this thing, and this, and x squared, right? But we remember the properties that it's equal to 2 over 3, right? So same thing as 2x 2 over 3, right? And we know that this is the n, correct? So 2 times 2 over 3 times x, right? And then of the minus 1 is negative 1 over 3 again, which equals out to 4 divided by 3x negative 1 over 3. That is your derivative for that. So basically, if I actually wanted to show the entire thing for x squared, I want to show you how tedious this is. 5x squared is going to be f, and well, the f is 1, so I'm just going to erase that. Okay, so it's going to be like this. It's going to be x plus h. This is how tedious. Minus x squared, right? Now, we already know that the derivative of this is going to be 2x, right? Because I dragged in and then 2, and then minus 1 is equal to 1, so 2x, right? But if I had to do this by definition, it would be more FOIL everything out like this. plus h minus x squared all over h. Eventually, this x squared and there's going to be an x squared over here will cancel out, and all you're left is with 2xh plus h squared. And because we apply limit as h approaches 0, substitute 0 for h, so therefore there is no h, and that just becomes 2x. Alright, so that's basically all you need to know for this power rule right now. It's very useful in solving very, 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 very large functions, and functions with coefficients and square roots and such, and that's basically it. You could also plug into your calculator, as long as it's tangent line, like if I have the curve x squared, can't draw properly, then the tangent line would go kind of like that, right? Okay, so the derivative is always the slope of the tangent line to that. So whenever you plug in your calculator, it should look something like that. Whatever function you have, it should be going like a tangent. That is how you use the power rule in order to find derivatives more easily. If you have any questions, do ask. If you have comments, please subscribe as well.